All right, so our final speaker of Act One, welcome to the stage, Daniel Reiff.
Hi everyone, my name is Daniel Reiff. Today we're going to be talking about microhydroelectric energy. So microhydro is actually a subset of hydroelectric energy, and hydro is one of the oldest forms of energy in our world. Now, it dates back to ancient civilizations, but more specifically, here at home, we have the Charlie Taylor water wheel up in Idaho Springs. Back in the day, during the gold rush, this was used to power a stamp mill that would crush rock down into powdered gold and silver during the gold rush. Now, more specifically, modern era, we have one of the engineering feats of our lifetime, the Hoover Dam. The Hoover Dam actually generates 2,000 megawatts of energy, and it's sited on the Colorado River, which generates an aggregate about 6,000 megawatts of energy across 7 states and 15 major dams. So how does hydroelectric energy work? Well, as we build a dam, the water level rises, which creates a ton of pressure, and that pressure, when we open the gates, flies down these giant penstocks or pipelines. That pressure and flow drives a turbine, spins a generator, and out comes electricity. What I think is super interesting is this is actually quite similar to how we generate energy from fossil fuels. So you take your coal, oil, or gas, burn it, generate high pressure steam, that too drives a turbine, spins a generator, and out comes electricity. So we know how we make electricity in our world. I was curious, how does US electricity portfolio look? Well, it turns out 21% of our energy comes from renewables, and within that, about 27% of that comes from hydro. And then, I was curious, so how does this look compared to the rest of the world? Well, you take any metric ever, USA, China, rounding out the top 4, but more specifically, you've got Canada and Brazil with about 2/3 of their energy from hydro, and then Norway coming in with a whopping 90%. So this is basically the landscape of traditional hydro. Macro hydro, if you will. The thing is, we've already dammed up all of our lakes and rivers. We've done the damn thing. So now the question is, are there smaller tier applications of the same technology? Absolutely. So here in Denver, we actually get most of our water from west of the Continental Divide. It comes to us from a tunnel called the Roberts Tunnel, and it brings water from Dillon Reservoir down to the Front Range. What's super cool is this is about 350-foot elevation drop, which correlates to a pressure differential. That flow and pressure is generating about 6 megawatts of energy, which powers a lot of Denver's infrastructure. So keeping in theme with Denver water, Denver actually manages over 3,000 miles of pipeline and over 500 pressure regulating valves. Now what these valves do is they actually take pressure out of the pipeline so that when water comes out of our tap, it's not like a fire hydrant, but rather the pressure that we all know and love. The thing about these pressure regulating valves, they are wasted potential energy. Instead of burning off that pressure, you could use a turbine to capture that energy in the form of kinetic energy and put it on the grid. So wouldn't it be cool if this existed as a technology? Well, sure enough, I actually work for a company called InPipe Energy, and we do just that. This is an installation that we put out in Aurora, Colorado just last year. This pipeline here is feeding the Denver airport, and then you have this yellow turbine here putting out about 60 kilowatts of energy to the grid. So how does this system work? Well, here's a rendering of our product. You typically retrofit into an existing pipeline that's going to break pressure via valve. What we do is we bypass that. We use a turbine to accomplish the exact same thing, and that energy goes back to the grid. So that's how microhydro technology works in the field. The question is, where else is it applicable? We talked about public water supply. The other 2 big buckets are agriculture and industrial water. So then I was curious, how much potential energy is there in the US? So the Department of Energy, Colorado Energy Office, they took a look and they determined there's about 1.4 gigawatts of hydroelectric power potential across the US, with Colorado actually being a top state. How does this correlate into our overall energy picture? So it ends up being about 15 terawatt hours of energy, and if you compare that to the annual new installations of solar and wind, you'll find that it's actually very much on the same order of magnitude of some of our favorite renewable energy technologies. So microhydro is beautiful from a quantitative perspective. There's also some fantastic qualitative implications. In terms of the materials to produce, primarily made of steel. Compare that to rare earth materials, fiberglass, which often ends up in a landfill, and you've got some fantastic scope 1, scope 2, scope 3 implications. And last but not least, as we all know, traditional hydro can be massively disruptive to marine ecosystems, but microhydro is leveraging the untapped potential energy of our existing water pipeline infrastructure. And so that is why, within the realm of renewable energy technology, microhydro is house money. Thank you.
Wow, just amazing talk. So again, the way these are coming together is really great. So microhydro also can be used as storage to some extent. You can use it kind of when you need it. So it's kind of the perfect renewable energy. So if you go back to the first talk when we talked about the different intermittent sources, hydro kind of fits in this kind of perfect puzzle piece. So it's kind of in the middle of all of that. And sorry, I mispronounced your last name. It was one of my only jobs is to check that out. So, but my memory is not that good. So Reiff. All right, you could pronounce it Reiff. Some could. Some did. Yeah.